Welcome back to the AWS Networking Series, Episode 3, well, technically 3B here, load balancing. We're here with Alastair Cooke. How you doing? Alastair's above you right now. How you doing, Alastair?
I'm good, Jeffrey. What's happening up in your ceiling?
It's you that's up on the ceiling.
Oh, hi.
Hi. So, anyway, what we taught in the first episode, Alastair outlined about ELB and how it's used and what it does in the whole process here. We're actually going to drill now into AWS and show you how to set up an ELB. Well, actually, Alastair is going to do most of the work. I'm just going to sit here and watch and ask questions every now and then. You can ask questions too. How do you do that? Well, go ahead, like, subscribe, comment, and then just ask questions down below. We will answer them when we get them and try and get you answers as quick as possible. So with that said, with that done, Alastair, take it away.
Cool. Thank you, Jeffrey, down there. So we're going to do a series of things. I've talked in the previous video about the three different flavors of load balancer, and so I thought we'd just build all three of them and look at the difference in the functionalities. So I've already got a couple of EC2 instances running my Al's Pizza website that we're going to use as the destination. So let's start with having a network load balancer in order to connect them. And you'll recall that the network load balancer is our highest performing, but not the most sophisticated load balancer we have. So load balancers are configured down here in the load balancers section of EC2. And in here, as usual, there is a wizard to get started with a new load balancer. So I don't currently have any here. I'm just going to create a load balancer. It says, what type of load balancer would you like to create? Well, we're going to start with a network load balancer. We'll start in the middle. What have we got to do? We've got to name it. Let's call this NLB Pizza. And we can see in here that we can choose whether it's internet facing, that is accessible directly from the internet, or whether it's going to exist only inside our VPC. I'm going to make this internet facing so we can connect to it from this machine. Load balancer listeners. So remember that listeners are the front end of the load balancer. And in here for the network load balancer, we can choose a few options about the incoming connections. I'm going to just stick with TCP port 80 inbound connection, but we could add an additional listener in here for TCP and just do port 443 on here. And that would allow HTTPS connections that come through on TCP port 443. At the bottom, it says, what availability zones do you want to enable for your load balancer? Remember, a load balancer is a regional service, so it happens potentially across multiple subnets within a single region. I'm just going to choose all three, since I have three availability zones available to me in Sydney.
So
talk about availability zones next video.
Will this add more if there is more?
It will show me all of the availability zones that my virtual private cloud, my VPC, has enabled for it. So in Sydney, there are three availability zones, and we'll talk about availability zones later. Most regions, there's three availability zones.
Okay, so most of the time you'll see three and no more.
Yeah, sometimes you'll see six, sometimes you'll see four.
Okay. And you don't have to choose all. You don't have to choose all six or four.
No, you absolutely. You can see that it's a checkbox for each one to choose.
Does that add more or take away more any value if you don't check all six or four or three or whatever?
You can add later, so you can extend to use multiple VPs, more availability zones later. But the more availability zones you use, the higher availability solution you can craft in this. And that's why I'm going to talk about availability zones next. One of the challenges teaching anything on AWS is that there are a series of interconnected concepts, and you've got to pick which ones you're going to ignore until later. Okay. And I'm letting availability zones go to the next video.
Okay. And one more quick question, and that is, is there additional cost if you end up choosing more than one?
So that's something I hadn't planned to look at, but let's take a quick look at cost. aws.com/elastic load balancing, I think, is the URL for it, or are we going to get a 4 out of 4 on that? Excellent, found the right place.
Cool.
So all AWS products have a page on aws.com, and there is always a pricing tab. If this pop-down doesn't get in the way. There is a pricing tab that tells you exactly what you're going to be billed for each load balancer type. So I'm currently working in Sydney, so it's offering me the Sydney pricing. And if we look at a network load balancer, it says what we're going to charge you for is having a load balancer at 2.5 cents per hour. So if I run this for all 720 hours in a month, then it's going to cost me about $14, $14.80 or something.
$14 Australian.
No, this is all US dollars.
US dollars?
All
Okay.
AWS pricing is in US dollars.
Okay.
And then it has a load capacity unit, and the load capacity unit at 0.6 cents per hour is dependent on the connections through.
Okay.
So as the direct answer to the question you asked, Jeffrey, no, using multiple availability zones has no impact on price.
Okay. Perfect.
It's purely about having the load balancer and then the amount of traffic or connections or active connections or new connections that go through.
So if you have if you do have 6 load balancers set up and you have traffic just bouncing back and forth, that's not going to affect anything on that aspect. It's just
so 6 availability zones. Yes, whether you use 2 availability zones or 6 is not going to change the cost.
Okay, perfect
for the load balancer.
All right.
So the next thing after we've chosen our once we've chosen which availability zones are named and set the listeners, we set some security. At the moment, we're not doing any SSL decode on our load balancer, so there's nothing to configure on that. Next thing is setting target groups. So this is where we're setting the destination side, what's going to actually receive these things. So we will call this the NLB pizza target. And it's going to be a set of EC2 instances. Now we can choose IP address here. You can use a network load balancer to load balance connections to things that are not EC2 instances running on AWS. The things behind this load balancer could even be on premises in your environment if you had the networking extended into AWS. Most of the time it's instances, so we're going to go and take a look at instances in here. The health checks are just going to be our TCP protocol health checks. We're not doing any other health checks on here, and so the advanced health check settings just say the threshold is 3 successful health check, and we have 10-second interval between health checks. We can override this and change the number of successful health checks that are required in the interval. The consequence of this particular default settings is that when you start up a new EC2 instance behind this load balancer, it's got to be healthy for 30 seconds before the load balancer will start sending it traffic. Also with these settings, it has to be unhealthy for 30 seconds before the load balancer will stop sending it traffic. So these load balancer settings are important. Next step is registering targets. So what things are going to be members of my target group for this load balancer? I have 2 web servers here called Web 1 and 2 that both have exactly the same configuration of my Al's Pizza website on them. So I'm going to add them to the registered sources. These EC2 instances you can see have HTTP access from the internet allowed for them. HTTP access will happen from the load balancer. Then it says you want to review this. Here are all the settings you're going to make. Take a copy of this for your documentation. And then you say, let's go do it. Let's create this application, this network load balancer. So it says, yes, we've successfully created a load balancer called NLB Pizza. And very shortly it will be available to us. Close out that dialog. And now we have our NLB. Down the bottom, you can see that we have a DNS name for this load balancer. And this is how we're going to access it. So we're just going to grab that DNS name. Now the load balancer probably isn't quite ready yet, but let's see if it is. So now you can see Al's Pizza website has come up.
I'm not looking at it. I'm too hungry at this point.
Yeah, and getting distracted by this text down here that says that it's the web server 2 doesn't compete with the special homemade sauce that we have on our pizzas at Al's Pizza. So we can see that as I'm refreshing this page, the load balancer is flipping us, sometimes changing us between the two web servers, sometimes returning us to the same web server. It seems to be giving us web 1 quite a lot at the moment. But we have received responses from both web 1 and web 2 through this elastic load balancer, our network load balancer.
Is there a way you can flip a switch to test to make sure that we're going to 2 and 3, or?
So we should just be going backwards and forwards between 1 and 2. So now we've got number 2 has returned this time.
But there is no way to test it just to make sure.
The way you test is as I'm testing it by refreshing.
Okay. Yeah, I was just curious because, you know, sometimes I'd like to be assured, and if I'm sitting there hitting refresh, and still getting web 1 and not getting web 2, I kind of want to force the issue, and that's why I was asking that.
Yeah, the nature of the load balancer is that as the client, I can't force which one. I'm not supposed to even care. So I've written this website specifically so you can tell which web server you're hitting.
Okay.
And that's common for debugging. But it would be really common for the client not to know at all which web server you're hitting. And that's the important thing about the load balancer. I'm using the same URL to access this site, no matter which of the web servers I'm hitting.
Okay.
So if there were 20 web servers behind here, I would still use the same URL, the same access method.
Okay.
Even if there was just one web server behind here, there are some interesting, weird uses where there can just be a single server behind this load balancer.
Okay.
All right, so that was our network load balancer. Let me just close out these spare tabs that we've got. What else did we say we were going to do in the demos? Classic load balancer for HTTP only was our next step. So let's go through the wizard and see how the wizard for creating a load balancer looks different if I take the previous generation classic load balancer. And you can see by the gray in here and the sparseness that AWS would quite like us not to be using the classic load balancer. And I'm expecting that over time that we won't be able to use this sometime in the future.
It'll probably go away. Is there any reason why you would need to use that legacy device? Is it like something that's really old or what?
It really is old. It's not quite as old as EC2 itself, which from memory was a 2011 service, or was it earlier than that? It is a 8 to 10 year old service.
Okay.
Probably more than that.
So it'd be like an app that never really did any type of updates, or maybe it was put in mothballs for a little while and they're bringing it out to try and restore something or whatnot.
I think there's a whole bunch of use cases where people have used this in previous architectures. 5 years ago, when I first started learning about the AWS infrastructure, it was the only load balancer there was.
Okay.
So there absolutely will be architectures that are expecting to work with classic load balancer. Classic load balancer is supposed to be a little less expensive than other load balancers, but when I was looking at the pricing, that pricing page, the classic load balancer looked like it's probably not actually going to save you any money against switching to an application or network load balancer. So classic load balancer, I've said I just want to listen on HTTP ports on port 80. Security in here. So the classic load balancer does also get a security group, the same as we saw in the previous video where we were configuring a firewall for incoming connections. So I'm setting the security group to use my standard public HTTP security group. That's the one that allows HTTP web access from the internet on this load balancer. We're not using HTTPS on here. If I'd gone back and set a listener to be on HTTPS for port 443, then installing an SSL certificate here would help me with offloading, but I'm not doing that for the moment. And then we get to configure our health checks. Now, because we're doing HTTP health checks, we get a path inside the website. Now here it goes to just the default path. But really, we should have a dedicated health check path in here. We should have an HTML file or a PHP file, since this is a PHP site, that does all of those dependency checkings. And again, we've got a response time. We've got an interval for how often we're going to do it. We've got an unhealthy and healthy threshold. Notice that here, the healthy threshold is 10 successful responses at 30 seconds. I'm going to decrease that because I'd like our our load balancer to become active in less than 5 minutes after it starts up. Then we can add our EC2 instances that we want to use for this load balancer. So I'm going to have just Web 1 and Web 2, the same as we had for the network load balancer. I'm going to create any additional tags. And then as usual, here's our review and create. Right. The create button, it goes out and creates our load balancer and says the classic pizza has now been created. I'm sure we can think of what toppings should be on a classic pizza, but now we have our load balancer here. And it's still in the provisioning, but we've got a DNS name available for ourselves here. So this DNS name is how we're going to access the load balancer when it becomes available. And again, as before, we do need to wait for DNS to update. The biggest delay actually here in the lab is my DNS server on premises has to catch up and all of the caches need to be caught up. The actual DNS out on the internet is probably already up to date. We'll just need to wait for my DNS in my lab. Now, after a couple of minutes, all of the DNS is caught up, and again, through that classic pizza URL, we get access to our load balanced connection into our two servers. So right now we've got Web 1 coming through, and if we refresh again, we get Web 2. Typically, my experience has been that the classic load balancer or any of the HTTP load balancers are better at switching back and forth. So Jeffrey, that uncertainty about whether real load distribution was going on is much easier with network load, with HTTP load balancers than it is with CCP port connection load balancers.
Good.
See, we're just flip-flopping backwards and forwards between Web 1 and Web 2 here every time I refresh.
Because you know I want my pizza.
Yes. And the more reliably we can connect you to the website where you can not order the pizza, the happier you'll be.
And not get it picked up or not get it delivered.
Yes, well, dine-in is not currently acceptable, so it's got to be delivery or collection. So we've now built a network load balancer that just listened for port 80 requests. We built a classic load balancer that listens for HTTP requests. It's just the application load balancer that's left, our smarter load balancer. Now, one of the things I've already created for us is another web server that's broken.
Ooh.
So we have this web server here called Web 3. And Web 3 has the Al's Pizza website, but I've removed all of the images from it. So if I copy the URL for Web Server 3, and I'll show you what we should get when we go to Web Server 3 is the same text, but no images behind.
No images, yeah.
Okay, so that's what Web Server 3 gives us. And I'm going to set up an application load balancer, first of all, just to give us Web Server 3. And then I'm going to have the application load balancer redirect the images path to Web Server 1 or 2 that do have the images folder.
No,
this is showing the multiple target groups.
So just to make sure that that screen that we just saw, which doesn't have images, will all of a sudden have images? Or
so when I first create the load balancer, it's just going to have Web Server 3, so it won't have the images.
Yeah.
And then I add the second target group and a rule that says if it's a request for the image path, go to the servers that do have images. Then suddenly that page will get the images. We'll refresh the page and it will have images.
So if you have a page that's causing problems, it will the customer will not see those problems there. That's pretty cool.
This is not really about faults in the page so much as breaking your website up into multiple subcomponents.
Oh, okay.
So normally we think of a website as being, here is the web server and the entire contents of the website is sitting on one web server. But when we're building more complex sites, we sometimes want to break it out. So part of the website resides on one web server and part of it resides on another.
Okay.
And we use the application load balancer to decide which of those sets of servers to send a particular request to, even though the client thinks it's all just one website because it's all just one load balancer.
Okay, that makes sense. And then you can break up your code and break up and you're
and it
always
really is about breaking up your code.
What's that?
It's about microservices architectures where different teams are responsible for different subsets, and those subsets run completely isolated from one another.
Yeah, that's where I was going. I didn't mean to break up the code physically. I just meant that you can break
Oh no, it
break up
really
pieces.
is.
Okay.
Yeah.
All right.
Right down to different teams who are responsible for writing the code.
And then I'm assuming there's also, you can also put in security. So you have one team that writes this code, but team 2 can't access that code and back and forth. Okay.
And then there's elements, as we'll see in the rules in here, where you can also use this, that although there is the same set of web servers behind, but some parts of the website we just say don't allow any access to.
Okay.
So it's on the web server, and maybe the web server uses it internally to reference itself, or maybe some back-end process talks to this web server, but the public side is restricted. So that's where we can use the load balancer as part of our security structure.
Yeah, so a nice compartmentalized system there.
Yeah. So let's create ourselves an application load balancer.
All right. I want some pizza.
And of course, it also is going to be called Pizza, but now it's called ALB Pizza. Again, internet facing. We are just going to do HTTP connections. At the moment, I don't want to get caught up in web server certificates for HTTPS.
Okay.
And again, we choose the availability zones that we want to use. I'm just going to choose 2 now. We don't have to choose all of them. The security settings page again says you haven't set up any secure listeners, you haven't set up any certificates. This is where it would set those certificates up. Next thing, security groups. And again, I'm going to allow HTTP access from the internet using the same security group that we used before. Then we configure routing. So where am I going to send this traffic to? Let's start with our basic one. So this is the broken pizza. This is the listener, the target group that is going to go to our the web server 3 that doesn't have the images.
Okay.
This target group is called broken pizza. And we're going to register targets behind that. We're going to take our web server 3, which has that broken website that's missing the images. It's the only one we're going to add at this point because it's the only one that should be in this target group. We'll go through and review, and it says, yes, you're going to create an application load balancer called ALB Pizza. It's going to be internet facing. It's going to listen to the usual stuff. Go create it. Bing, 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 create it.
All right, and we're back, and I don't see any photos. I don't see any images.
No, so no images, and you can see at the bottom that our platform is Web 3.
Okay.
And because we only have the one EC2 instance behind this target group, every time I refresh, I'm going to get Web 3.
Web 3, okay. That makes sense.
So we expected this to be no images. We got exactly what we're expecting. But we better bring in the other component of our website, which is the images.
Okay.
So we do that back here in load balancers, but instead of it being in the load balance section, we're going to target groups. And we can see in here we have a target group for the NLB, and we have our broken pizza target group. We're going to create a new target group. Unfortunately, I can't just reuse this NLB pizza target because it's a TCP connection load balancer. I'm going to recreate that load balancer as an HTTP connection. So this is going to be images pizza. Create the target group.
Success.
Thank you. Created the target group, images pizza. And then in here, we need to add targets. So I'm going to register some targets that are going to be behind this group. And we know both Web 1 and Web 2 have the images because when we had the load balancer using them, we got successful access to the images. So I'm going to add those two.
So you wouldn't want to check Web 3?
Correct. If I added Web 3 in here, it's got a different configuration. And that's a really important thing behind these target groups. All of the things behind the target group should provide exactly the same service. Okay. Because as far as the client's concerned, they don't know which one they're going to connect to. So they should all provide the same service. Web 3 clearly doesn't because it doesn't have the images folder.
So if you did have Web 3 in there, every time they refreshed, you could get images and then you might not get images, correct?
Yeah. Yeah.
Okay.
Consistency behind this is very important.
All right.
So now I've defined the destination the traffic is going to go to. Now I've got to define why the traffic will go there. And that's done back in the load balancer itself. So we go back into the load balancer, into the classic load, the application load balancer. And in here, we have a listener for HTTP traffic, and we have a set of rules. So the default rule says, if the request isn't sent anywhere else, send it to Broken Pizza, that's web server 1. But I can add an additional rule. So I can add a rule that says if the path in the requests is /img star, then forward the traffic to the target group with the images. So requests that start with /img/ will go to the images pizza target group, and every other request will be sent to web server 3, which is the Broken Pizza.
Okay.
So you can see in here that we could, path by path, choose where to send traffic. We could have different collections of web servers behind each path.
Yeah.
And we could have a rule at the bottom that says just drop the traffic if I haven't already told you where to go. It would be more secure than saying everything goes here.
Like a 404 page?
Yeah, or we could, the end rule could be just essentially black holing it, not even 404.
Okay.
In terms of security, the best practice is to not respond to an invalid request rather than giving it 404.
Okay. But in this web
there's
case,
a web server here, but you've tried to access something that doesn't exist.
But in a web case that we're explaining now, that would be a 404 page.
Yeah, in this case, right, if it's not in the images path, it'll be satisfied out of our target group that's got web server 1 in it.
Could there be a rule set up that says if that image does not exist, here's a placeholder image to put in its place in the spot?
Not in here. You'd do that in the web server itself.
Okay.
And mostly this isn't used to just find images from somewhere else.
Oh, yeah,
mostly this is used to separate out different parts of your application.
Yeah, I was just figuring if there was some sort of code that, if it wasn't there, that it would completely break the application, then having a alternate code that just catches it just in case would be in place.
Yeah, you can see that the rule sets that are in here is reasonably complex, but not hugely complex.
Okay. So the main coding should really be in the web server, but this is just a catch.
Yeah. Yeah, so this is just straight up which part, mostly it's which paths, which request type you're using.
Okay.
So now that we've allowed access to the images, we come back here to the site. If we cross our fingers and hit the refresh button, there's the images. The actual HTTP code is still coming from web server 3 that doesn't have the images. But every time we hit the /images path, it's being redirected to the web servers that do have the images path.
Okay.
Phew, demo worked.
One more question, and I know this is probably not why this is supposed to work this way, but could you have images different on web 1 and web 2 and then set that up and all of a sudden it's A/B switching?
So in terms of being able to do A/B or red-green, you'll see that our forwarding rules here are not particularly, not the most sophisticated. Actually, that's not where I wanted to go, was it? That's taking me to the EC2 instance. We can do a rule in here. Come on, let me add a rule. Let me just edit this one then. Edit this rule. We can do in here to say, I want to add, we've done 100%. So let's just edit this one and say we're putting a weighting in here of, let's add another target group. So if we're adding in here to have a, let's look the even. All right, so we can do a weighting between two target groups here, or two target groups as the destination. With this particular configuration, every second refresh of the page is going to have no images, because it's going to go back to that broken for all the images.
Okay.
But yeah, you can do weighted loading, and you could use this in order to do a A/B or a blue-green deployment configuration change.
But that's not where you would normally do that.
It's one of the places you could, but yeah, I would normally do that kind of AB or blue-green through a DNS in front of this. So you remember that we've got these really ugly DNS names on our load balancers.
Okay.
So this long DNS name that's all about. Normally we would use something like Route 53 as a DNS service to sit in front of it and put a friendly name in front of this. And then when we're doing that blue-green deployment, we'd have a whole new load balancer, and we would change Route 53 to point to the new load balancer.
Okay.
Sure. So that was the last demo that I wanted to show, was the use of the application load balancer with 2 target groups and the ability to have rules controlling which requests go to which target group. So we've seen the network load balancer giving us very simple configuration for TCP port connections. Chose to use port 80, it could be any TCP port. I used the classic load balancer to give us very basic configuration of HTTP access. And did you notice that there was no target group in the target groups list for the classic load balancer?
Yes.
And then we set up the application load balancer, both with a single target group, but also with 2 target groups and some rules controlling traffic between.
Okay.
Cool. Jeffrey, any other thoughts about load balancers?
No, it, once again, looks pretty straightforward. The setup is, there could be some points where certain checkboxes are checked, and of course, you have no images in your pizza place, but those look like they can be easily fixable. And I'm assuming if you get stuck that there's going to be somebody at AWS that can help unstick you.
Yeah, so always with AWS, your first place is start looking on the intertubes. But if you have a support relationship with AWS, there's a lot of human beings who will help you with dealing with your problems as you go through.
All right.
Cool. Well, yeah. Next video is going to be talking about why we have multiple availability zones and setting up a highly available configuration across your networking and load balancing.
All right. Well, there you go. Well, thank you, Alastair. I learned a lot about load balancing. That's awesome. And of course, hey, you guys out there, don't forget to like, subscribe, comment, and ask your questions. Technical, we could try to answer technical questions, but that's best for an AWS either agent or somebody that you'd hire to help you with that. But definitely, if you have any comments or questions, ask them below. We'll see what we can do from there. So, this has been another AWS episode, and don't worry, we'll also get out of AWS and do some other stuff as well. But we're going to continue with the AWS and get you a good pizza with a lot of meat and a lot of vegetables on it, so you can set up your own websites as well, and other applications for that matter. So Jeffrey Powers here, for Alastair Cooke. Thank you guys very much, and we'll see you next time.